Hi, my name is Jillian Johnson with Christian Brothers University, and I'm going to be going over my senior project capstone, which is using a electroencephalography system to run OpenVibe, a software that allows real-time data visualization of um, EEG information systems and allows you to create brain-computer interfaces with them, um, such as controlling things in virtual reality or physically manipulating things, possibly, or um, to create really cool real-time biofeedback of the information you're collecting from the system. So OpenVibe is the software platform that was mainly used to drive these visualizations and um, these outcomes, and it was developed by the French Institute. Um, I have written down here the French Institute for Research in Computer Science and Automation, and that's what INRIA stands for. So INRIA.fr, part of their web URL, that's where the software comes from. So um, I am using the 2.2.0 version, and yeah, I'm gonna give you guys a tutorial and show you what kind of things the software can do. I can't, full disclosure, I can't actually run any of it because I cannot access the lab with the EEG system to record on it. So, okay, let's start out by showing off the acquisition server. And let's close all of these things. Oh my gosh. Can we close that? Let's just close like all the things. Should have done that beforehand. Um, hmm, very cool. Hope you guys aren't seeing my files. Anyway, so this is the acquisition server. This is where you connect the EEG system to the software and and do the checks to make sure that it's working properly. So the driver, you can choose what type of driver um, you would like to use for which kind of EEG system you're using. As you can see, there's a lot of different options here. I have been using the Brain Products ActiChamp because that's what we have in our lab, but you can use a lot of different types of platforms, ranging from OpenBI to Brainstorm. You can even use like generic oscillators to create create and manipulate signals. Yeah, a lot of really cool options. Um, Driver properties options, just update the software. You can do that, and you can choose how many electrodes you're using. So again, I'm going to be basing everything off of the Brain Products ActiChamp EEG system, and in the lab we were using the 32 channel EEG, but it does have capabilities for 64 channel. Um, yeah, so let's get out of that. Um, and again, you can choose how many samples you want as well out of that system. Um, and then in preferences, if preferences will open up for me. Does not look like preferences is opening up for me. Very cool. Very, very cool. maybe if I close it and reopen it. Oh, look at all those errors. That looks great. Uh, uh, okay, cool. So in this server, um, you can correct for drift, and a lot of times, especially if you're running any of the boxed scenarios, you'll have to change this to letting the driver decide, especially if you use markers, which specifically in the ERP scenario, which I'll show off later, you have to let the driver decide it, and it'll be able to set markers up in your data. And that's mainly what this is for. And as you can see, this plugin setting shows that off. Um, and that's the acquisition server. Yeah. So if I had a system hooked up to this, I would be able to connect it. And as you can see, it's trying to connect, but it fails because nothing's plugged up. But once your system is connected, you can hit play, and then whenever you hit play, you can then run you can then run your plugins or your nodes and your things you've built through Designer. So you really have to hit that play button for any of this stuff to work or function. And once you have that up, you should have this this play thing available, and that will pop up very cool visualizations of whatever you want. Um, So yeah, that's the acquisition server, very important. And then you can also stop it. But I think a really cool aspect of this is that you can play and stop the server without disconnecting it. So that's kind of neat. So I will close out of this and not be coming back to it. So the Open Vibe Designer is really cool. This is where you can create your own nodes and your own layouts and make this is the bulk of the program. This is where all the work happens, really. And there's a lot of different things you can do with it. These four are um, processes that I've built to show the real-time biofeedback of the system, and I'll going to explain that in detail later. First, I want to show off some of the um, kind of box tutorials that you can get from this. So this one is it's a generic topographic map. So it goes node by node to get something that will end up looking a little bit. Can we exit out of that? I don't know. Don't look at that. um so it will end up the topographic map will end up looking something a little bit like this. But um yeah, so it comes with a lot of different box tutorials that you can kind of place on here and get something to open up and to figure out how the system really works. Lots of cool things. You can also even plug in MATLAB, Python, and Lua scripts to to direct what things happen. So cool. But yeah, let's go through the topographic layout. So generic stream reader, what generic stream reader does is, oh yeah, and all of the box tutorials have descriptions for what each node does, and you can open up You can also open up documentation for each node as well to learn more, but it'll pretty much just say what's in this box. Anyway, so yeah, generic stream reader, it it opens up a file that you created or that is already here or is already on it for you to kind of play around with. Reference channel references everything against whatever uh, reference node you have. So yeah, this is where, oh yeah, and if you click on each box, like it'll do things. So so yeah, reference channel, you just set whatever reference, in this case it had it as NZ. For generic stream reader, you are able to, I'm going to move because my parents are about to come in and be loud. um Hopefully I'll be able to edit this a little bit. So yeah, so generic stream reader, you're able to open up a file, and I think all of them are .ob files, which is specifically an open vibe file type. And you create the .ob files through a generic through a node called generic stream writer, and that basically records any kind of input that you've had, any kind of input or history of EEG activity that you've recorded. So temporal filter, it basically just acts as a filter to signal any kind of range. So um, so this is the beta range, which is 16 to 24 hertz, and you can do all different types of ranges from, but most of the I think all of the ones that I've created have been in the alpha range, which is I want to say 8 to 13. Why is that 1 to 3? Is that alpha? I know this one's alpha. Yeah, it is 8 to 13. Okay, cool. Um, so time-based epicing, basically like for how long you want each epoch to be in seconds. Simple DSP runs, I believe this one is a simple, it this set does an average, so it multiplies two signals together and then averages them, um, and that does an epoch average, so it does the DSP over each epoch, um, and and then from the output of that, and another cool thing is that each little node by color means different things. So the okay, why are you doing that? I'll explain that on another one where I can actually get this to function correctly. um, but so the 3D topography does it as a does the map as a 3D visualization like that, and then a 2D map. There's not a 2D map on this page, but it's basically just a flat cartoon face and the brain orb, or not orb. It'll be a circle with whatever activity happens on it. And then the electrode localization file reader that reads a file of just electrodes and electrodes with their placements, and it reads the electrodes with their placements and their coordinates. That's the word I'm looking for, with their coordinates. So I will close out of that, and I'm going to go on to describe each of the biofeedback, um, okay, I'm not going to close out of it, to the biofeedback packs I've made. So, does this have 3D cubes? Sorry, I have this page open up that looks at the different kinds of visualizations. Um, I don't think that's the cube. No, it's not. Let's see if I can find this. Open Vive 3D cube. Does it show what it does, or is it just documentation? Nope. Oh, it does. Okay. So, this is what the 3D cubes will look like. It just kind of have cubes in abstract places with it will when I say abstract, I mean it's not. It just doesn't have a head to put it on. Like it's you choose different coordinates. So I'm assuming this is uh front facing coordinates, and then that's back coordinates or channels. Um, and so for each channel, each electrode, whenever heightened activity happens in whatever temporal filter range you have, which that looks kind of like alpha. That's alpha and that's enough of alpha range for it to happen. But so actually, let's just open these up side by side. So so we're getting information from the acquisition client, which the acquisition client is the acquisition server. So once you hit play on that and you hit play on this, what is happening? Okay, sorry, my computer's being very slow. Um, so once you get information from the acquisition client, it will send it to the reference channel. And so in these, so yeah, so I have CZ as the reference channel. Um, and then, so that's just a configuration mode. And then, so, oh, yeah, oh, is that what I did? Yeah, that is what I did. Okay, so, no, that's not what I want. Whatever. Um, so it sends it to, so I have four different links here, and that's because each different length has different um, filter settings, so it's looking at different different frequency ranges and frequency bands. So this one will be alpha frequency band, as you know. So as you can see, it looks at things from 8 to 13 frequency range, and it uses a bandpass filter, which simply means that it filters out everything except for this specific range. Um, and then, so from that filter, it does epicing from second intervals. It does a simple DSP. I believe this is also and just x by x, yeah. So multiplies two signals together, then it averages the signals, and does an average of the time, and then it outputs to a 3D cube. So that would look something like this, and in this case, the alpha case, um, which is kind of the easiest one to see a reaction from. So when someone would close their eyes while hooked up to the EEG system, they would relax and their alpha signals would be set off, specifically in the uh, pos- posterior section of the brain, and the electrodes at those areas would grow bigger. So you can see in this image, these cubes are red, and this doesn't have any kind of uh, coordinates on it, but the red means there's higher activity. So there's higher activity in the posterior alpha, which makes sense. When the closing our eyes and making the alpha activity happen. So using that, you can kind of use that information to say something is happening. And when you're able to discern that something is happening as opposed to nothing is happening, you're able to create inputs and a feedback like that. So this is a really important visualization for that, this idea of being able to signal that something is happening with just your brain activity in your eyes. Um, Yeah, so this one, it is the same except for the filter ranges from 12 to 18 hertz, which I believe is beta, and I could be wrong on all of these. Actually, let's just Google. Let's use our really cool nifty friend Google. Uh, Beta frequency range. So 12 to 30 hertz. Let's find that one. That's 4 to 8. Hmm. Not quite 12 to 30. It's 1 to 1 to 3. Very cool. Looks like I don't know what I'm talking about. Um, Gamma frequency range 25 to 140. I don't know what I did on these. But anyway, this one is definitely alpha. So let's look at the alpha topography. So again, we're looking at the acquisition client that sends it to a reference channel, and the reference channel goes to the temporal filter, which we have as alpha. And that then does a time-based epicing, simple DSP again, multiplying the two signals together and then averaging the signals and then averaging the epochs. And in this case, we're selecting the specific channels that we're looking at, just so it kind of cuts down on the information coming into the system and being output into the visualization. So the computer runs a little bit better and the information and graphics are a bit more clear. Um, and then it does the 3D cubes, it does the topography, and it does the 2D topography. And with the 2D topography, you do need this localization file reader. But so like I was saying, with the colors of the inputs and also the outputs, you can choose the type you want. So in this case, because we're coming from a signal average and an epoch average, it's going to be a signal. But you can change that to a spectrum, which you can change that to a spectrum and to a streamed matrix. But we're keeping it as a signal, and I'm just canceling that. So the blue means it's a channel localization, and click that, nothing happens. And the input of this, it does interpolation. So that's cool. Great. That's alpha topography, and that's what, and so basically this just does like all of the cool things with the alpha filter. So this is continuous bars. Anyway, yeah, so for continuous bars, and I'll have, have this open. The continuous bar that'll show, not that, not that. We could also do this. This is kind of cool. This is tomographic visualization as opposed to topographic visualization, and this gives you some really, really cool possibilities when you have this thing open and are able to adjust the settings. And another really cool thing is that once you have these visualization boxes open, there's even more settings that you can build on. And the really cool thing about the tomographic is that you are able to visualize very specific parts of the brain and internal structures. So it's kind of like it gives like a little bit of like an fMRI aspect to it, but not not really. um Anyway, continuous bars. Yeah, so this is the bar view. So this is what the continuous bars would look like. And it basically scrolls from like this is time, and these are the different electrodes. So you choose what electrodes you want to be seeing. Um, and I don't know why instant bars isn't showing. Instant bars open vibe. Will you have the visualization, please? Okay, well, what I just showed you was the instant bars. So let's look at continuous bars. I'm gonna have to edit this a lot. Um, so continuous bars. Okay, cool. Anyway, instant bars. Instant bars is very cool. Um, but we're looking at continuous bars. So continuous bars are very cool, and you can so this is what the continuous bars layout will look like. And basically the this line, this green line, it sweeps across the screen and refreshes every time it gets across the screen. um and it shows again real time biofeedback, and the bars go up. The bars go up based on activity. No, wait, why is I don't want to end the meeting. I want to continue. Okay, rude. Um, oh, I hope I can edit this. Um, anyway, so you can so as it scrolls across the screen, the the activity goes up, the bars go up when the activity goes up. And it does this by pretty much the same thing I set up the 3D cubes for, but I added the continuous bars. And so it's supposed to be filtering for the main different types of frequency ranges, but I don't know. I still don't know why I have those numbers on there because they look wrong. That's something I'll fix if I ever get to see the lab again. Single tier. um, so this is instant bars. So instant bars look like this. So again, time. So time is the x-axis, and the different electrodes that it's looking at are the y-axis, and the activity for each electrode goes up when more activity is happening for it. So when it comes to the alpha, which again is the easiest thing to kind of be able to detect, and when you have posterior channels or posterior nodes or electrodes, um, when you have it set up like that, when you close your eyes, the activity in the posterior should be able to should kind of like rise up faster. Yep. Um, and so I want to say there were there were other ones that I made, um, specifically with the bars, but we can go through the visualizations. So oh, and there's bitmap. Yeah, so so for all of these visualizations, really, it's the same kind of layout with the same channel of information, but for different but for different visualizations that you'd want. Um, so this is pretty much the same layout as this and this, but with instant bars, but with continuous bars, but with 3D cubes, and then this one is just for like everything, I guess. um, so 2D topography does a 2D visualization, 3D cubes do the cube thing. The tomographic visualization is the activity and kind of the specific brain structures. Um, 3D topography does the 3D head map. Continuous bars do that, or no, do the thing I showed before that. That's the instant bars. A continuous oscilloscope. I don't think I've played around with that one much. I think it actually does just straight up take like oscilloscope information and plot it like. Oh yeah, the most basic visualization is the continuous oscilloscope. Wow. It shows it just shows off the signal activity. Um Fun time. Really fun time. Bars, but where's the signal? Okay, whatever. It's fine. That's good enough. Yeah. Signal display. That's it. It's example of raw signal display. So, continuous XYZ plot, I haven't really messed around with that one that much either. Yeah, these are the options you have. Oh, and the bitmap. Yeah, so definitely have that one here. So bitmap map kind of cool shows a cool time frequency analysis of whatever electrodes you're looking at. So this is the horizontal version, and I believe the vertical version just has the axes flipped. And you, again, like there's a lot of different really cool things you can do here. And then you can also have Python and MATLAB plugins. Are you guys ready to check out some more cool things? Some super cool, more cool things that you can do with this that OpenVibe already has installed. Crazy. So let's close out of everything here. Quit without saving. I'm going crazy. Because I have everything saved, I think, already. Anyway, what am I looking for? Let's open Designer back up. I hope it doesn't open with the files I just closed out of. And I think it will. Cool. So let's close out of everything. Because if I don't, my computer will crash. See, look, it's not responding that well to anything I do. We're trying here. We're really trying to make this work. Please. Please close out. Please. Thank you. I hope you close out too. Yay. So now we're gonna open some more files. Because I have lots of things running, I guess I can close you too. I just have a lot of things saved on here because, like, my computer's my life, I guess. It's my life now. Let's look at some BCI examples. So here's recording for ERP. This is pretty neat. Um, we're gonna open these files, and we're also gonna, if we can open, let's try harder. Open, please. No. Cool. Open. Oh, this is a fun time. Um, cool. It opened one file at a time. Yeah. Oh, we're really making this work. We are really making this work. Cool. So ERP recording. This is kind of cool stuff. So mm, now let's open the scenario launcher. We're opening so many files today. So this is the scenario launcher, and as you can see, the acquisition server is not running. So this is actually pretty cool. Oh, hey, it doesn't do that? Cool. So let's not look at this. But let's look at it for a second, actually. So the ERP stuff, it's pretty cool. You can record event-related potentials, possibly. Um, I wasn't able to get this working because in the version I had, the marker plugin wasn't working, which I don't know why it wasn't working on the lab computer, but it is showing up on this one. It's probably the versions. There was also some weird things happening with the versions to get it to run with the ActiChamp. So as you can see, like this one says Menzia Technologies, but the other boxed ones were under Enria. So I think Menzia is the Brain Products version of this software, and which just works with the Brain Product stuff, but then everything else works with everything other than Brain Products because of some weird software overlap. Um, but anyway, so on the original version, you can run the ERP stuff, but on the Menzia version, you can't run the ERP stuff. On the Menzia version, you can only run the SSVP, motor imagery, and the P300 speller BCI applications. And I only really did research and look into the motor imagery and the ERP stuff, but then I found out the research I was doing into the ERP stuff wasn't really worthy of my time because it wouldn't work anyway with the Mencia software. So yeah, this is what I'm looking at. So the acquisition client. Um, it sends it to the generic stream writer in the signal display, and it does a signal display of the signals that you're getting, and then it sends like stimulations, which stimulations are a um, something that is a Lewis script that opens up a sound, and that's what's supposed to trigger the ERP, um, and then so to do things like that. Well, cool. I guess we're looking over this. And then it does things. This records it, and then this replays the recording. So yeah, it'll send the beeps, beep beep. It'll send the beep in the sound player, and it'll display the cue image. Um, but yeah, so that I did a little bit of looking into it, enough to try to get it, and did enough looking into it to realize that I couldn't do it. Hey, and let's try to close all of these out again, so I can open up more things. Whoa, I don't even mean to go full screen, but I guess that's working. I guess that's what's happening now. Yes, close without saving. So let's open up the ERP stuff. Not the ERP stuff, the motor imagery stuff, because that stuff's kind of cool. This is actually what the main thing that I wanted to get working. Um, and before the school closed down, I had just kind of gotten to um, all of the biofeedback stuff working to the point where I felt comfortable moving into this space. Cool. So let's open this stuff up one by one. What time are we at for this recording? Am I still recording? I really hope I'm still recording. I'm still recording. Very cool. I can't see how long I've been recording. That doesn't matter. So this is something that could work in the lab with settings set up, because it does run through Menzia. Um, and I think this is the coolest thing that this program can do right now. So basically, so the idea behind the the motor imagery task is that you should be able to move your left hand, and the activity based on the movement of the left hand in the brain can be recorded and can be used as data to train activity for when you're thinking about moving your left hand. And so basically, when you're physically moving your left hand, it will give off a signal, and then when you're thinking about moving your left hand, it will give off a similar but weaker signal, but still a distinguishable signal that can be used to train data. And that data can be used to train the computer to pick up on that and say, this thing is happening. And what's even cooler is that you can use the same thing for the right hand, and it will be able to discern different information for you moving your right hand, and the same weaker similar signal for thinking about moving your right hand. And so that activity can be differentiated and used to be put into, in this case, an online environment where you're thinking about moving your left hand and a ball will move left on the screen, or you can think about moving your right hand and a ball will move right on the screen. And what's even cooler about that environment is that that environment can be ported into a virtual reality setting. So there's a lot of potential for really, really cool applications here, especially if you're just discerning those two signals with like limited amount of electrodes. So like say like 4 electrodes, and you could hook that up to say like a brainstorm, which or not maybe a brainstorm, but anyway, any kind of EEG system that does that has like minimal minimal wires and um connections set up, and you could possibly hook that up with a virtual reality system and be able to move things in the virtual reality system without any kind of controller, just your brain activity. So there's a lot of cool future research with this stuff. This is, I want to say it's cutting edge, but eh, I don't know what I meant by that. Anyway, it's cool stuff. So the motor imagery, it has four different phases that correspond to four different box tutorials. I don't know why 3 has online and online incremental. I guess it's just different ways that you could do the online porting. Um, and then you have the initial software to monitor the signal and just make sure that the signal is coming in. So you have the acquisition client that filters, does a temporal filter, from 1 to 40, and it takes the signal and looks at its filtered and raw components. And here's some information about what exactly things are done. So the first thing, which is the acquisition, which is acquisition of training data, which basically just means, so so this is a warning box that I accidentally opened. um so yeah, so this is a acquisition of training data, and it uses a Lewis stimulator, which is just a script, which is a pre-written script to do GRAS visualization, which the GRAS visualization box is basically a box that tells you to think of moving your hand left or think of moving your hand right. And um, so the acquisition client collects the information and then sends it to the generic stream writer, which writes a copy of the data information that you're getting while the stimulator is running, and then it also sends it to the player controller. So the player controller, not 100% what that one does. I think it just sends feedback. Oh hey, let's press F1. Let's try to learn more about this. Because you can press F1 to mute, I guess. No. Oh, I'm having a great time. Oh, cool. So that's not gonna work. So let's just move on. So this is the step where you train the filter, you train the data in computer um to look at the information. So yeah, so the stream reader, which is the file written here by the stream writer, the stream reader goes into the identity and goes to reference channel, selects a channel, does some math stuff, filters it out, and splits it up. We're great. We're running great. Splits it up into, I'm assuming like a left identity and a right identity, and then classifies that information. Yeah, so um, what you get from that stimulation is more information that is used to classify the signals you're getting from the EEG system. And so this box, the brain computer interface. Sorry, I've been drinking coffee all day. I don't know why I'm yawning. But anyway, so that information was used to train the spatial filter, and now this information is going to be used to train the classifier. So the difference between that is that the spatial filter classifies this it classifies like where exactly the information is, and this trains information based like using that using the using the information of where it's coming from to classify what is happening. Does that make sense? I Yeah, it makes sense enough. Um so this the the, the spatial information the the spatial information was trained, and then now the information that was trained is being classified. So using the acquisition client now, um, instead of the recording of the information. So you're streaming that, and then it writes another file which will be used in the fourth scenario, and then so we're classifying using the information and saying reference channel, selecting the channels, doing math stuff, filtering out, doing more signal stuff. And then here is where you're classifying what is exactly processing the information. And here again, you're using the stimulator um, to do things. The stimulator will show up a box. Again, yeah, it'll show up the box telling you to move your hand left or move your hand right to say like where's the activity coming from. And so I guess that this takes the information based on the increments instead of all at once. So I'm just going to close out of that. If it'll let me close it out, maybe it won't. Whatever, we're moving on. So in this last one, this is actually launching the online scenario where you're able to physically control it and control the thing. Um, so showing a culmination of everything that happened, or it's like a replay of everything that you did. So so it's a replay of everything you did just to make sure that all the information was run correctly. Um, so the generic stream reader, which reads from the file created in either one of these, either one of these from the stream reader, which it still won't let me close out of. But so yeah, it looks at the identity and then goes through all the signal stuff. It's reading reading through it, classifying the processor, doing the simple DSP, and then moving it into the GRAS visualization. And let me, can I, can you please look at more information on this box? Because this box is really important. And I know the GRAS is the name of the researcher that, well, it is working. He's the name of it's the last name of the researcher that kind of put all of this stuff together to make the motor imagery stuff work. GRAS experiment, that's what it's called. Yeah, so all of this stuff is called the GRAS experiment. And and it is a brain computer interface paradigm, but what does this box actually do? I think it's just the display. Yeah, I think that is a visualization. It duh, it says that. But oh, anyway, yes, the visualization, it does the thing. It shows a box of you moving your hand. It shows a box of like an arrow going left and an arrow moving right. Anyway, so all of this is recorded, all of this is trained, all of this is replayed to check if it's being done correctly. And all of that is so you can go into this scenario launcher. When you launch the acquisition server, it will send or so anyway, so to use all of this aligns with the scenario launcher. So when you click this and when you edit this, what are you doing? When you edit this, by editing all of these, you run this to give the information to all of this, and then once you have everything set up, once you have everything trained, you launch the acquisition server and you launch the signal monitor. You launch the signal monitoring to make sure signals are coming through, but you launch the acquisition server in here to run the actual experiment, and you can then move your hand left to make a ball go right, or you can, yeah, you can move your hand left to make the ball go right, and you can also think about moving your hand left to make the ball go right. To think about moving your left hand to make the ball go left, and you can move your right hand to make the ball go right, and think about moving your right hand to make the ball go right. So yeah, that's my senior project. This is what I've been working on, and I I don't want to end my meeting yet. Thank you. That's that's what I've done. That's what I've worked on. That's what I've learned. It's a really, really cool uh, project and software, and I think it has a lot of potential. And I really wish I could be able to show off the actual visualizations of things I've created. Um, but it's really neat stuff, and I hope to work on it in the future. This has been great, and I hope I'm able to edit this. Bye.